Starting off at the respiratory chain, which is where the final processing of electrons and hydrogen happens, and also where the most ATP is generated. A special chain of redox carriers will receive electrons from NADH and FADH2, which were previously generated by the Krebs cycle in glycolysis. Electrons are then passed subsequently from one redox molecule to the next, and the flow of electrons allow the active transport of hydrogens outside the cell membrane where the respiratory chain is located. In the finalizing step in the transporting process, oxygen will receive hydrogens and electrons and then produce it into water. Note that this process does involve consuming oxygen. Elements of the electron transport, starting off with ATP synthase. Because NADH enters the chain as the first carrier, it then sets the rest of the 6 steps in motion. During every redox exchange, the energy level of the reactants is decreased. Therefore, the released energy is caught and used by ATP synthase. ATP synthase is stationed along the membrane in close association with the electron transport system carriers, and like I said, it captures and releases the energy from the ETS carriers. Each NADH that enters the electron transport chain gives rise to 3 ATPs. This coupling of ATP synthesis to electron transport is called oxidative phosphorylation. NAD and FMN enter the electron transport system at a different point, so there is less energy released and only give off 2 ATP molecules.
So to pretty much break down what chemiosmosis is, it's basically when ions move by diffusion across a semi-permeable membrane that's inside the mitochondria. When this happens, it sets up a concentration gradient of hydrogen ions called the proton motive force. This illustration pretty much just shows you the process of how chemiosmosis takes place. So proton motive force is pretty much energy that is generated by the transfer of protons or electrons across a membrane that can be used for chemical reactions. It consists of a difference in charge between the outside of the membrane and the inside as well. Separation of charges temporarily stores potential energy and can only diffuse into the membrane through ATP synthesis, which sets the stage for ATP synthesis.
Hi guys, my name is Leslie Flores and I'm gonna talk about the proton motive force. The transfer of H positive through a proton pump generates an electrochemical gradient of protons, called a proton motive force. It drives the conversion of ADP to ATP through ATP synthesis. This process is known as the chemiosmotic theory. Um, H plus gradient drives the production of ATP and powers active transport. All this consists of a difference in charge between the outside of the membrane positive and the inside that is negative. As you can see here, this side is positive and this side of the membrane is negative. Separation of charges temporarily stores potential energy. H positive can only diffuse into the membrane through ATP synthesis, which sets the stage for ATP synthesis. And here there is a short video I want to show you that explain a little bit more about all this. I
In the
hope you
mitochondrion,
can
the energy
understand.
stored in NADH is used to generate a proton gradient across the mitochondrial membrane, and the energy of the proton gradient is used to make ATP. When glucose is oxidized during glycolysis and the Krebs cycle, the coenzymes NAD and FAD are reduced to NADH and FADH2. Inside the mitochondrial matrix, the electrons from NADH are transferred to the electron carrier coenzyme Q by NADH dehydrogenase, and the protons are transferred across the membrane to the intermembrane space. Coenzyme Q carries the electrons to the cytochrome BC1 complex. As the electrons move from the BC1 to cytochrome C, more protons are carried from the inside to the outside of the membrane. Electrons are also transferred from FADH2 to coenzyme Q, with the protons being transferred across the membrane. Cytochrome C transfers electrons to the cytochrome C oxidase complex. Protons are also transferred to the outside of the membrane by the cytochrome C oxidase complex. The cytochrome oxidase complex then transfers electrons from cytochrome C to oxygen. The terminal electron acceptor and water is formed as the product. The transfer of protons to the intermembrane space generates a proton motive force across the inner membrane of the mitochondrion. Since membranes are impermeable to ions, the protons that re-enter the matrix pass through special proton channel proteins called ATP synthase. The energy derived from the movement of these protons is used to synthesize ATP from ADP and phosphate. Formation of ATP by this mechanism is referred to as oxidative phosphorylation.
And I think that's it, and thank you for watching my video.